Today's agenda is going to be a little bit different than Monday's agenda in the fact that I promise this video will not be as long as Monday's. I know that was really long, but we just really needed to cover that material, and there really wasn't any other way around it. But I apologize for that, and I promise that this one will not be that long. Today what we're going to do is, well, you've already gone over your mole calculation worksheet, numbers 1 through 8, and had some volunteers place those problems up on the board. Hopefully everybody's on the right track, and if you weren't, you were able to see some examples and ask questions of the volunteers and figure out what you might have done wrong. So we're kind of moving on from there today. All of that stuff was review from Chapter 3 first semester, and so now we're going to kind of start talking about some new stuff, really applying what we learned there. Those were the basics, and starting to get a little bit more into where we really use this stuff. So what we're going to start talking about today is molar mass. So if you could get into your notes, your guided notes, your 7.3 page where we left off, well, not yesterday, but Monday, if you could open that up if it's not already, and we're going to take a little bit of notes. I'm going to show you some problems, work them out with you, and then I'm going to let your table partners and you do some problems. Then we'll go over those answers, and after that I'll let you work on the next set of problems on that mole calculation worksheet. So if you guys are ready, we'll go ahead and get started. So what if you got this question? What would the mass be of 1 mole of methane? So last night's homework, you had similar questions to this. You know, they asked you what would the mass be of 1 mole of carbon, for example, a single element. But now they're giving you a compound, multiple elements that have been bonded together to create this compound. So how do we do that? We can't just look up methane on the periodic table and do our little conversion factor of 1 mole is equal to the mass in grams from the periodic table. So what do? Well, the first step is to figure out what is methane. Now, methane is one of those weird compounds that doesn't actually get named like all of the others, with our cation being the first full name and then the anion being the one with the ID ending. Methane is kind of a weird one, and that's why I'm using this example, just so that you know that they are possible. If you were to ever run across one, I would always tell you what it was, just like I'm going to do here. So don't ever worry that I'll give you one of these on a test or quiz or anything like that. So methane is CH4. It's a carbon and 4 hydrogens bonded together. So we can say it's 1 carbon and 4 hydrogen, or what this is actually saying is that there is 1 mole of carbon and 4 moles of hydrogen in this particular compound. That's what CH4 is telling us. Not only is it an ingredient list for the recipe for methane, you know, just like 1 cup of flour, we have 1 carbon and 4 hydrogen, but a little bit deeper than that, we are actually saying that there is 1 mole of carbon and 4 moles of hydrogen. To find the mass of methane, we sum the masses of carbon and hydrogen together. So we have to do this kind of in steps. The first is to realize that we need to add up the carbon individually from the hydrogen, and then add both of those together. So the first thing we do is we kind of make a list of what we have, and in this case we have carbon and hydrogen, and we have 1 carbon, and each carbon is 12.01, and I'm getting that 12.01 from the periodic table. That is the atomic mass from the periodic table rounded to 2 decimal places. So 1 times 12.01 is 12.01. We have 4 hydrogens, and each hydrogen is 1.01. Again, I'm getting that 1.01 from the periodic table. I'm reading it directly off of there. I'm just rounding it to 2 decimal places. It's technically 1.008, so I'm rounding it to 1.01, multiplying it by 4 because that's how many I have, and I get 4.04 grams of hydrogen. And then I add those two together to figure out the total mass of methane. So 12.01 added to 4.04 gives me 16.05 grams of methane. So if you were asked the mass of 1 mole of methane, this is how you do it. This is called the molar mass. It's just simply taking each individual element out of the compound itself and then adding each individual and then going back and adding the total. And that's really honestly all it is. So definition, let me give you the definition of this because molar mass is one of your vocab terms for this chapter. Molar mass is the mass of 1 mole of the substance. So molar mass is the mass of 1 mole of the substance. And that substance can be anything. It can be any type of compound. It really honestly doesn't matter. In the methane example, that 16.05 grams we got at the very end, that is the molar mass of methane. And that's never going to change. 16.05 grams of methane is the molar mass. And you can't change that because methane can't be anything but CH4. So that's kind of nice about molar mass is it never changes. So what if we were given this problem? Find the molar mass of sulfur dioxide. Okay, I'm going to switch over here to my OneNote so I can write it down. So the first thing that we have to do is we need to write down what is sulfur dioxide. What is the actual chemical formula for that? Well, to figure that out, I'm just going to use my rules that we learned all last week. And what I notice about this name, sulfur dioxide, is I notice that Di. I know that di is the prefix for 2. And immediately I know that I am dealing with a prefixes compound. And I notice there is nothing in front of the sulfur. And I know that little rule that says if the first one is 1, we don't use anything. So my compound in this case is SO2. Sulfur dioxide is the name for SO2. Alright, so now I can actually find the molar mass of this. The way that I like to set up my problems is to keep it kind of nice and organized, make sure I don't miss anything. So I make a list of all of the elements involved in this particular compound. This is a nice one. There's only 2, just a sulfur and an oxygen. And then right next to them I will put how many I have of each. So I have 1 sulfur and I have 2 oxygens. And next to that I have put a times sign because I am going to multiply them by their mass numbers from the periodic table. So I'm just going to come over here to my periodic table, and I see that sulfur is right here with 32.065, so round to 2 decimal places, that's going to be 32.07, and oxygen up here is 15.9994, so that's going to round oxygen to 16.00. So sulfur is 32.07, and 1 times 32.07 is 32.07, and 2 times 16.00 is 32.00. So Now that I've got each individual, I can add them together. So I just add these, and I will get 64.07 grams, and rewrite your compound SO2. So 64.07 grams of sulfur dioxide is my answer for the question of find the molar mass of sulfur dioxide. Now I would like for you and your table partners, and if your table partner is missing today, feel free to join a neighboring group. And I want you to find the molar masses of polyvinyl chloride, which we call PVC if you ever go to a hardware store and get that white plastic looking pipe, and we usually call it PVC pipe, which is just short for polyvinyl chloride, which is C2H3Cl. For water, ammonia, propane, and glucose. So if the sub wouldn't mind to pause it right here, and I would like for everyone to find the molar masses of each of these compounds. Okay, so hopefully everyone's had time to work with their table partners and figure out the molar masses of each of these chemical compounds. If you look under the picture there, you'll see the answers to these. I'm just going to kind of talk you through what you should have done to get these answers. So for the polyvinyl chloride, you should have added the 2 carbons, 3 hydrogens, and 1 chlorine together to get 62.50. Carbon is 12.01, hydrogen is 1.01, and chlorine is 35.45. For water, you have 2 hydrogens and 1 oxygen. Hydrogen is 1.01 and oxygen is 16.00. For ammonia, you have 1 nitrogen at 14.01 and 3 hydrogen at 1.01. And when you add all of those together, you get 17.04 grams. For propane, you have 3 carbon at 12.01 each and 8 hydrogen at 1.01 each. Add them all together and you get 44.11 grams. And for glucose, we have 6 carbons, each 12.01, 12 hydrogen, each 1.01, and 6 oxygens, each at 16.00. Add them all together and we get 180.18 grams. Okay, so it's just making sure that you don't make any silly mistakes. Take it slow. Make sure that you round that number off of the periodic table to 2 decimal places. It really does make a difference. It can really alter your final answer if you don't do that. So always just make sure that you round that to 2 decimal places, and then also round your final answer to 2 decimal places as well. So what I would like for you to do right now is, and you may work with individually on this, or you may work with your table partners, or I'll leave it up to the sub with how you would like to have them work on this. But same worksheet as from last night, you are going to do problems 9 through 14 of the mole calculation worksheet. When you finish these problems, 9 through 14, with the remaining time in class, you are welcome to finish up working on your naming practice worksheet, which is going to be due next class. So both of these assignments, 9 through 14 of the mole calculation worksheet and the entirety of the naming practice worksheet, will be due on Monday. So take this time in class where you can ask questions of your neighbors and work on these 2 things. And I will see you on Monday.